The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, good morning. We have a lot to cover today, so buckle your seatbelts. I want to start by looking at a problem from the test. And the reason I want to go over this problem is because most students missed it. And so I just want to clarify what should have happened. This is problem number 3 from the test. Now, you may have had a different number that's the number in red there, but I think everybody had a number times x squared. All right, now, the situation is this. It says simplify the expression, assume that the variable is unrestricted, and use absolute value symbols when necessary. Okay, so if the variable is unrestricted, that means that it could be positive or it could be negative. So initially we'd get 2x as our answer. However, since x can be negative, and when you take the even root, in this case, the square root of a number, you can't get a negative answer. So since x could be negative, we have to put absolute value bars on it. Okay, now I want to do just one more problem. And let's take a look at this next one, number 4. On this one, several people put absolute value bars around the z and the x. There shouldn't be any absolute value bars because it says all variables represent positive real numbers. Therefore, we can safely assume that z and x are both positive. Okay, that's all I have to say about that. If you have any further questions, feel free to reach out to me outside of class time. Okay, so now we are going to start into chapter 10, and we're going to look at section 10.1. Can everybody see my whiteboard screen? Just make sure I've got the right thing going on there. Somebody? Anybody? Didn't hear you, Sarah. Was that a yes?
Yes, that was a yes.
Okay, thanks. Thanks. All right. So we're going to look at something called the square root property. Now, we just got done with a chapter 9, where we solved equations containing radicals by isolating the radical on one side of the equation and then squaring or cubing or raising to the 4th power, whatever it took on both sides of the equation. Now we're going to go the other direction. We're going to have an equation that is called a second degree or quadratic equation. And we're going to solve it by taking the square root of both sides. So kind of going in the other direction. First of all, I want to look at an example. Let's say we have x squared equals 9. Can you see that if x is 3, 3 squared equals 9? That, yes, that is correct. X equals 3 would be a solution. But what about x equals negative 3? Negative 3, the quantity squared, is also 9. So this equation, x squared equals 9, has 2 solutions. Now, we did that just by kind of looking at it, but there's a process, this process that's called the square root property, where we do the following. We get the equation in the form that it is right here, where on one side of the equation we have a perfect square that contains the variable. On the other side of the equation, we have just a constant or just a number. Once it's in that form, we take the square root of both sides of the equation, which gives us this. However, we just concluded earlier that there were 2 solutions. So the way we cover this is when we take the square root of both sides of the equation, outside of the radical on the right side, we put a plus or minus. So x equals plus or minus 3. Now, that's the notation that mathematicians use, and the way it's said, you'd say x equals plus or minus 3, which refers to these 2 solutions. However, in WebAssign, it does not accept this notation. So what you would need to do in WebAssign would be to write your two solutions, separating them by a comma. So perhaps it would say x equals, and then you would put -3, comma, space 3 as the solutions. Okay. Any questions about that before we look at a bunch more examples? All righty. Here's another problem. This says, put on my glasses so I can see. All right. We have w squared minus 47 equals 0. So the form we want, on one side of the equation, we want a perfect square containing a variable, and on the other side of the equation, we want the constant term. So what I'm going to do is add 47 to both sides of the equation so that I get that. Now it's in the form to use the square root property. So I'll take the square root of both sides of the equation, not forgetting to put in the plus or minus, okay? You do that anytime you take an even root in this context, whether it's square root or fourth root or sixth root, but mostly we're going to focus on square roots. So then I get w equals plus or minus the square root of 47. Now, we just got through with a chapter where we learned about simplifying radicals. So if the square root of 47 could be simplified, if something could be brought outside, we would do that. It turns out that 47 is prime. It doesn't have any perfect square factors. So our solutions would be w equals negative the square root of 47, comma, the square root of 47. I also want to point something out. When you're writing your answers, make sure that you move outside of the radical before you put in that comma. Because if you write it like this, where that comma is still inside the radical, most likely WebAssign will not recognize it and will mark it wrong. So be sure that you move outside of the radical before you put in the comma. All right, let's see here. We have x squared minus 101 equals 0. So again, I'm going to write the wrong number. I'm going to isolate the perfect square term. Boy. All right. So we're going to take the square root of both sides of the equation. 101 does not contain any perfect squares. So basically, x equals negative the square root of 101, comma, the square root of 101. Okay. Another example, u squared minus 24 equals 0. So we will add 24 to both sides of the equation and get u squared equals 24. Then we'll take the square root of both sides of the equation and get u equals plus or minus the square root of 24. Now, the square root of 24 can be simplified because 24 is 4 times 6, 4 being a perfect square. The square root of 4 is a 2 on the outside. So u equals plus or minus 2 square roots of 6. So u equals negative 2 square roots of 6, comma, 2 square roots of 6. And you don't have to put the plus sign in front of the positive one, okay? Any questions about that example? Okay, let's take a look at this one. Here we have the quantity x minus 1 squared equals 4. It's already in that special form. On the left side of the equation, it has a perfect square, meaning 2 identical factors, and it contains the variable. On the right side, we have a constant. So what we're going to do now is take the square root of both sides of the equation. So on the left side, I get x minus 1. On the right side, I get plus or minus 2. The square root of 4 is 2. But I haven't solved for x yet. So I'm going to add 1 to both sides. Now I have x equals 1 plus or minus 2. That 1 is in front. So that would give me x equals 1 plus 2, which is 3, x equals 1 minus 2, which is negative 1. So x equals 3, comma, and negative 1. Any questions about that example? All right, let's take a look at another one. Let's see here. We have s minus 7, the quantity squared, equals 9. This is already in that form where we have a perfect square containing a variable equal to 9. So we'll take the square root of both sides of the equation. Don't forget the plus or minus. So we get s minus 7 equals plus or minus 3, the square root of 9 being 3. Then we'll add 7 to both sides of the equation. So s equals 7 plus 3, which is 10. S equals 7 minus 3, which is 4. So s equals 10, comma, 4. Those two solutions. All right, let's see here. One more example. This says, let's see, what does it say? It says let f of x equal the quantity x plus 3 squared. For what value or values of x is f of x equal to 7. All right. So basically, let's make that little to 7. That's a question mark. So basically, we're going to substitute this in the place of f of x. So now our equation becomes x plus 3 squared equals 7, or 7 equals the quantity x plus 3 squared. In other words, I could also have written it this way. I just like to have my square on the left side of the equation, but it works either way. So now we'll take the square root of both sides. We get x plus 3 equals plus or minus the square root of 7. Let's get rid of that. Okay, so now we're going to subtract 3 from both sides. So x equals negative 3 plus or minus the square root of 7. We can't do anything to simplify the square root of 7. So x would be what? Negative 3 plus the square root of 7, comma, negative 3 minus the square root of 7. And those would be the two solutions. All right. Anything there? Any questions there? Okay. Well, that's it for section 10.1. I'm going to go ahead and stop the recording and then start a new recording so that on YouTube there'll be separate videos. But anyway, 10.1, not a whole lot there in terms of what we're doing. But again, before we go, any questions about the 10.1 stuff? I say before we go, we're not going anywhere. All right.